Hey guys, it's Miss Hagan, and I am back again. Woo! I know that's what you think whenever you see me. But today what we're going to be talking about is climate and environmental science. So climate is really important, okay? But a lot of people get climate and weather confused. So what's the difference between climate and weather? Which one takes longer? Yeah, climate lasts longer. This is the one that we generally see over a long period of time, like a year, okay? So they might say, oh, it's a tropical climate, or oh, it's an Arctic climate. I want to live in an Arctic climate, but it's an Arctic climate. Weather is more like, oh, it's raining outside, or it's really windy, okay? There's a hurricane, that kind of thing. That's weather. All right, so there are 6 different things that make up climate. And today I'm gonna go ahead and list all 6, but today we're gonna only focus on 2 of them. But the 6 things that determine the type of climate, so we're gonna say factors for climate. Okay, 6 things. 1 is latitude, okay? And which way does latitude go? Does it go like this or like this? It goes like this, okay? It's long. Well, it's not long. It's horizontal. This is longitude, and it's long. Horizontal, latitude, okay? Then we have atmospheric circulation. And then we have, of course, oceanic circulation. Oceanic circulation. Okay. Then we have local geography. So this is if like you live in the mountains, or versus if you live by a body of water, like you live by the ocean. So the person who lives at the ocean, like in Florida, their climate's going to be a little bit different than the person who lives in Nebraska. Okay. Then we also have solar activity. So this is be like the changes of the seasons, how much sunlight the area you live in gets. And then volcanic activity. And if you guys remember, we talked about volcanoes in another video, and we talked about how volcanoes can be detrimental to the atmosphere with all the stuff they shoot out, and it can circulate around the atmosphere and cause it to the earth to cool down. Okay, so these are the different things that make up climate. But today we're only going to focus on the first 2. We're going to focus on latitude and atmospheric circulation. Okay, so we've already established that latitude goes horizontally around the earth. So you tell me, what is the key or the most notorious or well-known latitude? The equator, yes. Okay, so we have the equator. Now, the equator has a number associated with it. All lines of latitude have numbers associated with them. The number for the equator is 0. Okay, a big 0. So we have 2 different types of latitude, though. We have low latitudes, and we have high latitudes. So if the number for the equator is 0, what do you think? Do you think the lines are near the equator is low latitude or high latitude? Okay, it's going to be low latitude. And the reason it's low is because the equator is 0. Okay, so these are the lower numbers. Now, low latitude, this is near the equator. Okay, near equator. Now, near the equator, is it hot or cold all the time? It's pretty hot, okay? They have higher year-round temperatures. Okay, now do you think that they have a lot of change in the season there? Not really. I mean, it stays pretty warm. Their seasons are not very dramatic and change. So they have small variation in seasons. Okay, and because they're getting a lot of sunlight, so they have solar we're going to say they have greater solar radiation there. And they also have 12-hour days, or daylight, not days. Whoa, that's a short day. 12-hour daylight and 12-hour nights. Okay, so they have 12-hour daylight and 12-hour nights. So this is pretty even, okay? Here in Georgia, our days are not necessarily always even, okay? And we'll talk about that in a second. So that's what happens at a low latitude. Now, if you're at a high latitude, are you near the equator? Probably not. So this is, I'm going to say far from equator, okay? Our temperatures vary, okay? They can get really hot or they can get really cold, but normally they are lower year-round temps compared to the areas near the equator, okay? Now, we have a large variation in our seasons, okay? So I can't wear the same clothes year-round. I mean, I could, but I would be very uncomfortable. So there is a large variation of seasons. Okay, we get less sunlight, so this is why that is all happening, because of our location on the planet. Okay, and then we have a variation or a change in daylight depending on the season. Okay, so like here in Georgia, our days, our time for daylight gets longer in the summer but shorter in the winter. Okay, so that's what that's talking about. So this would really influence your climate, okay? What's happening there, especially with temperatures, okay, and your seasons. All right, so that's latitude. Now let's talk about atmospheric circulation. Now, in order to talk about atmospheric circulation, we have to do a little bit of throwback here to when we were either in physical science or physics, okay? And you talked about conduction, convection, and radiation. Those three words should sound kind of familiar to you a little bit, all right? Today what we're going to be focusing on is convection. Okay, so convection. Now convection is when you have heat being transferred through currents. So we have currents in the air, currents, that's a U. Okay, so we have air currents and we have water currents. Okay, think about the ocean. Waters, plural, whatever. Come on, Miss Hagan, get it together. All right, so now in order for convection to work, the way that we have currents is we have warm and we have cold, either air or water. Okay, so I'm going to make a little table here. We have warm air for the atmosphere, and we have cold air. All right, so you guys should remember, so it's kind of, you might have been told this quite often, but what happens to warm air? You're right, warm air rises, okay? That's why when there's a fire, you need to, in your house, you need to crawl out because the cold air sinks. Okay, it goes to the bottom. Now, one thing about warm air is that it also holds a lot of water vapor. Now this is why here in the South, we get a lot of thunderstorms in the afternoon in the summer because the air is warm and there's a lot of water vapor in the air, and we have these thunderstorms occur. And so that's why we have that happen here. That's how I remember that. Now, cold air is denser than warm air. And this makes sense because what we mean by denser is that it's heavier, okay? So it is going to be on the bottom, which makes sense because it sinks, okay? Now, in order to have a current, this is something that's going kind of in a circle like this, okay? So what that means is that as warm air rises, it expands and cools as it rises. Okay, so it starts to become cold air. Cold air, on the other hand, it compresses and warms as it sinks. Okay, so I'm going to draw a picture that might help you visualize this. All right, so I'm going to draw a circle here. Don't make fun of my circle. Kind of looks more like an egg, but whatever. It gets the job done. Okay, so I'm going to use red for warm air, blue for cold air. So I have my warm air rising, okay, and it starts to expand and cool, and now it has become cold air. As my cold air is sinking, it begins to compress and warms. Okay, so let's look at this. I have my warm air rising. It's going around. Now it's kind of cold, warm. It's in between. Becomes cold air as it sinks, and then it becomes warm again. That's why there's two colors there. Okay, so that's really important because this allows these currents to occur, this whole circulation for the air to be complete, make this circle. This happens in oceans as well. Instead of air, it's water. So warm water, warm or cold water is causing this to happen. Okay? It's very important that we understand what's going on here. All right, so we got one more thing to talk about here, and that is about the winds. Okay, so when we talk about wind, we have winds going all around the earth, okay? And we call these winds prevailing winds. And one way that you can remember that they're called prevailing is, what does prevail mean? It means it continues on, okay? So prevailing winds blow around the earth throughout in one direction, not the band, throughout the year. Okay, so we have two types. There are trade winds and westerlies. Okay, so if you ever watch like a pirate movie or something, they might talk about these. So we have trade winds and we have westerlies. Okay, now one way that we can view these guys is normally if you go and Google, Google this. So if you Google winds or trade winds or westerlies, you'll get a picture of the earth. Okay, I'm gonna try drawing the earth. No promises. Okay, so you get a picture of the earth, and on the earth picture, you'll have these lines. Okay, and in the lines, there'll be these arrows, kind of going like this. One will point that way, the next one they point the next way, then they point the other way. Okay, these represent the different types of winds. Okay, so trade winds, they occur 30 degrees north and south of the equator. Okay, so on my drawing there, this middle one is going to be the trade winds. Okay, now the trade winds, well, we'll come back to that in a second. I'm getting ahead of myself. All right, now the westerlies, they blow between 30 degrees and 60 degrees north and south of the equator. Okay, so that means these two guys here, those are my westerlies. Okay, cool beans so far? Awesome. All right, so now depending on the hemisphere you're in, they're gonna blow different ways. So, and for the trade winds, if you're in the northern hemisphere, I'm just gonna write hemi for a hemisphere, they're gonna blow northeast. Okay? If you're in the southern hemisphere, they're gonna blow southeast. That makes sense, right? Wow, that should have been purple. Way to go, Miss Hagan. Okay, so we'll do this over here. And I left off the N on northern. Why did you not catch that? Okay, so for westerlies, if you're in the northern hemisphere, oh, I remembered the N this time. Okay, they're going to blow, which way do you think? They're actually going to blow southwest. I know, it's weird. Okay, and then in the southern, they're going to blow northwest. Okay? So, that is about the trade winds. That is way the wind works, and the wind helps us have atmospheric circulation. So it's blowing these currents and trade winds around the earth. Blah, blah, blah. All right, so that's all you need to really know about climate. If you guys have any questions, hit me up on my email. You can leave a comment below and let me know what's going on. And hope you guys have fun learning about climate. All right, peace out, Girl Scout.